Welcome back to the classroom. Today's topic is the study of different types of processors. This video is sponsored by Genreviews.online. Genreviews.online is one of the review portal site. There are three types of microprocessors, namely RISC, CISC and EPIC. RISC uses a small set of simple instructions that are executed in one clock cycle, while CISC offers a larger set of complex instructions that are executed at a high speed using special purpose circuits. RISC chips are easier and cheaper to design, but they require repeated simple operations to execute larger programs. On the other hand, CISC processors reduce program size and require fewer memory cycles, resulting in faster execution speed. Examples of RISC architecture include EPIC and PowerPC, while examples of CISC architecture include Intel and AMD. EPIC, which stands for Explicitly Parallel Instruction Computing, combines the advantageous features of RISC and CISC processor in its architecture. Instead of relying on fixed length instructions, it executes instructions in parallel, enhancing the efficiency of these processors. This is achieved by utilizing a set of complex instructions that include both basic instructions and information on executing parallel instructions. Next is, what are threads and computer processor or CPU? Threads are virtual components or code that divide the physical core of a CPU into multiple virtual cores. A single CPU core can have up to 2 threads per core. For instance, if a CPU has 2 cores, it will have 4 threads. Similarly, if a CPU has 8 cores, it will have 16 threads and vice versa. How thread works? Threads are created by processors. Whenever you open an application, it automatically creates a thread that handles all the tasks specific to that application. The more applications you open, the more threads will be created. Threads are always created by the operating system to perform tasks for specific applications. There is a primary thread, also known as the code of that core, which performs computations. When it receives information from the user, it creates another thread and assigning the task to it. If it receives another instruction, it creates a second thread and assigns the task to it, resulting in a total of 2 threads. The best example is a smartphone app is an illustration of this concept. When you launch the app, a spinning circle appears, which is made possible by a dedicated thread. Another thread is responsible for loading and displaying the information in the graphical user interface GUI. The number of threads that can be created is determined by the physical CPU, and this limit differs from one CPU to another. The first image represents the loading spinner created by the first thread, while the second image depicts the GUI loading process carried out by the second thread. Next is, what is the use of thread? Why are threads important in computing? Threads play an important role in enabling processors to handle multiple tasks simultaneously, resulting in faster task completion and allowing computers to multitask. Threads are what allow you to browse the internet and listen to music at the same time. Next is the study of macroprocessor. A macroprocessor is a tool that provides convenience to programmers by allowing them to use macro instructions. These macro instructions are expanded in the main source code, making it easier to write code. Macro definitions can include formal parameters, and when a macro is called, actual parameters are specified. The macroprocessor replaces each macro instruction with a group of source language statements, which is known as macro expansion. Using macro instructions allows programmers to delegate mechanical details to the macroprocessor. The design of a macroprocessor is independent of the computer architecture it runs on. The process of macro expansion involves definition, invocation, and expansion. Macro expansion can be performed using 2 types of language processors, and when a macro name with a set of actual parameters is used, it is replaced by the code generated from its body. There are 2 ways to perform macro expansion, using a macro assembler or a macro preprocessor. A macro assembler expands each macro call in a program into a sequence of assembly language statements and assembles the resulting assembly language program. On the other hand, a macro preprocessor only processes the macro call. Other statements are processed with the help of an assembler. The macro preprocessor simply expands the macro in the program. It generates an assembly program in which a macro call has been replaced by statements that results from its expansion. However, statements that were not macro calls are retained in their original form. This program can be assembled using an assembler. This is a brief study of the processor role in a PC. Thank you for watching.